Example number 5. The correct statements among the following. We have to choose which of the statements are correct. The first statement, the spin angular momentum of the electron is a constant and it cannot be changed. What do you mean by spin angular momentum? It is nothing but mu s. Mu s is equal to root of s into s plus 1 into h by 2 pi. So this is a formula to calculate the spin angular momentum. Spin angular momentum. Therefore, it's a constant for a given electron. Means if I take one electron or two electron or any system, the spin is a constant. What is this S? S is nothing but the total spin. Total spin. How do you calculate the total spin? It is the sum of individual spin. Sum of individual spin. For example, if you have 3 unpaired electrons like this, a p orbital having 3 unpaired electrons, how do you calculate the total spin? Total spin will be half plus half plus half. That will be 3 by 2 like this. Therefore, for a given system or for a given electron, the spin angular momentum is a constant. Therefore, this is a right answer. Then the second formula is root of s into s plus 1, there is no dot here, h by 2 pi equal to root of 3 by 4 into h by 2 pi. That means if s is equal to some value, for some value, you can get these spin angular momentum as root of 3 by 4 into h divided by 2 pi. H divided by 2 pi. The spin angular momentum of the electron is a vector quantity. They have given that the spin angular momentum is a vector quantity. Yes, it is true because spin momentum itself is a vector quantity. Therefore, spin angular momentum is a vector quantity. Next, third option. Spin angular momentum is a vector quantity and it can have two orientation. So if you take spin of any electron, it can be either plus half or minus half. It is represented by spin up or spin down, a downward arrow and a upward arrow. If it is upward arrow, that indicates that the spin is equal to plus half. If it is a downward arrow, then it will be minus half. Therefore, option C says that spin angular momentum is a vector quantity, no doubt. It can have only two orientation. What are the two orientation? Plus half and minus half. So this plus half and minus half tells you the spinning motion of electron. The spinning motion of electron. Even that's also right. If you consider the last option, the spin quantum number explains rotation of electron in clockwise and anti-clockwise direction. This is absolutely wrong because spin quantum number is nothing but mu s. Mu s can have only two values, plus half or minus half. That we know it. This will not tell you the rotation of electron. It's not a rotational motion to tell the rotation of electron. It is nothing but the spinning motion of electron. How does electron spins around its own axis? Only that motion it's going to define. It is not about the rotation of electron in clockwise and anti-clockwise direction. Therefore, the correct statements are A, B and C. A, B and C.